Hello everyone, I'm Casper. I'm the founder of Testimony, where we help our clients make sure that they deliver their software fully cooked instead of half-baked. And here on YouTube, we help the aspiring QA engineers become test automation engineers, one slice at a time. And today's topic is going to be, I would say, top 10 or maybe even top 5 of all the interview questions for all automation roles you are ever going to stumble upon. And basically, regardless of whether you're applying for a junior position or a mid position or anything, you will come across this question. And of course, this channel is aimed towards people who are just getting their feet wet into the field. So this is geared towards the juniors, but I think everyone would find some utility in this because this is one of the most important concepts in test automation. And if you are starting out, this is one of the first things you should understand. And the topic of today's lesson is the page object model. So let's jump to our whiteboard. So the topic is the page object model and why you should care. And to understand why you should care, I think it would be really good to start with how does testing actually, automated testing actually work as far as the structure of all the scripts, of all the code is concerned. And don't get discouraged, it is not going to be hard to understand, but I think that tackling it from this perspective, rather than just giving you some encyclopedic definition of this, is going to be way easier to understand and it'll stick way better. So let's start with this. So if you never had any experience with automation before, then I think you imagine test automation and the structural workings of the code work something like this. Let's say we have some website. We are going to use a web application as a backbone of today's lesson. It's not like it's any different for different things, but it just will help get the point across easier, I think. And it'll be very easy to extrapolate to other domains once you understand that. So let's say you have some website, there's some logo, then you have, for example, some forms. Let's say this is some form, there's some buttons on the form, then there's some text fields, you can have some checkboxes, then the send button, stuff like that. Then you have some text in the right pane. Let's say that there are just some, headers, then there's smaller text, header again, smaller text, and so on and so forth. Let's say you also have some navigation here at the top. So let's just say you have like some buttons that may help you navigate through the website. Let's just say that you have some web application that you want to cover with your tests. So if you are not really experienced in test automation, you may imagine that, all right, so we have this website, so we create some big script that just goes through the motions. So we imagine how the test would work from a person, like an actual human being interacting with the website, and then we try to convey it using the code. And so we just go end to end, like point after point, like as if you were creating a manual test case, for example. So this is one of the problems you may come across. Since you are a QA engineer already, you may understand testing from the perspective of actually writing out the steps you need to do in order to reproduce a bug, for example, or as a series of steps that you can just point out one by one that show you what to click and what to interact with in order to have something happen on the website, like regression test cases, for example. So if you try to use that logic for automation, like if you try to translate it one-to-one, it is going to be a bit problematic, and we are going to talk about why that is. So let's say you do it. You do what we just talked about. So you try to somehow convert what would actually be a manual test case into test automation. So let's say you have to have a test case that would validate like the fields on this form, for example. So normally you would just go, one, go to website, then you'd have two, like scroll down, and so on and so forth. And then you would have like validate this, validate that. So let's say it would be like 10, validate X, then 11, validate Y, and so on. So if you try to make that a script, then you come across some problems. So first of all, if you try to cram all of this test case into some script, let's just say maybe that this script is going to be something like, let's say, script. And then you just have all of this, but translate it into code. So you have, in this script, you have all the locators, because you need to somehow pinpoint the elements that need to be interacted with. And if you don't know what locators are, or if you don't really feel comfortable with them, I really recommend you to go to our mini-series on locators, and especially the first video, the locators first aid, if you don't really want to know the technicalities yet, because if you do, we also have an XPath crash course. The links will be in the description. There's a separate playlist for this. So I really recommend you do that in order to understand where the problem lies in this scenario, and what locators are and why they should be there. But if we consider that you know what locators are, then you should think that locators should be in the script. Some methods that allow you to interact with the website, because you have to somehow, like click, use some drop down, scroll something, try to input something. These are all actions that need to be performed on the actual website. So by these methods, I mean actions. And then we also have the tests. So you may think, yeah, that's exactly how we should go. Since the test case written in manual testing form looks like this, then the script should look like that. And, that's easy, right? And so it's not that easy, regretfully, because you should see that this may get really ugly really quick. And the reason for that is that you are, in this scenario, cramming everything into one script. And it may look like a good idea until you stop to imagine how many scenarios you usually need to cover, how many paths you need to cover. That very often you have a couple of things to test on a given page, and then another things on another page, and these things sometimes intertwine. Like you may have a situation in which the locators you used here will actually be used in another script too. Like you also have script 2 for another page, for example, and then it would use, for example, the same locators. So you need to copy the locators from that script to another one. And also it may use the same actions. So you may have to copy it again, because suddenly, for example, the upper navigation bar is something that is like cross page. You have to interact with it on different pages, or for example, you need to log in before performing some of this stuff. So on each and every script, you need to implement the logic for logging in, and for inputting your credentials, and for using the navigation, and for all the action methods. And you may think, yeah, but since I have already created that once, why can't I just copy it? Like, it's easy, right? Yeah, it is, but very soon it won't. Because it's easy if you are creating a sort of proof of concept and you have like 1, 2, 3 scripts and that's it. It's not easy when you have a ton of scripts and they need to work between each other, and it's a huge code base, and there's a lot of intertwining happening. It stops being easy when suddenly something changes on the website and you need to change it in all the places, and suddenly the locators that were fine and you copied them between the scripts, suddenly they need to be updated everywhere. And suddenly the methods also change because something changed regarding the navigation or how the login works or something like that. And suddenly you need to change it everywhere. And sure, even though your scripts may not change, like if, for example, if this was still the manual testing realm, it may very well be that you wouldn't be concerned with all the changes. It may very well be that even if something changed, it would be like a very quick change in the test case in the written format. Or it may also be that even some big changes in navigation or in action methods would not really entail too much change in the manual test case, because it may very well be a very small change, or it may not be a change at all, because as a human being you can eyeball it. But still, please refer to the locators video. The technology cannot eyeball it. So you cannot tell it like, yeah, there was some changes, but don't really get to wind up about it. Just carry on. It may be that the logic changed a bit, but still the description was so vague that the change does not really concern you, but it will concern the machine when it will try to actually do something. So then you will have to make the change everywhere. And the more scripts you have, and you will have a ton in basically all professional environments, the more headache you have, the more places where you need to change stuff you have, the less portability and reusability you have, the less possibility for actually the code base being easily maintained there is. Because this will grow fast, and it'll grow at a rate with which you won't be able to keep up at some point. And so, to remedy all of this, because this, as we can see, it just doesn't scale. And scalability is a big part of every organization and every project. So you can say that this does not scale. It just won't work for big projects, because you will have so much spaghetti code at some point that you won't be able to keep up, and your team won't be able to keep up. And so in order to actually fight that, we have something we call the POM, or the Page Object Model, which is the topic of today's lesson. And so POM is the abbreviation of Page Object Model. It is a design pattern that actually helps you with problems like this. So POM, the main thing that the POM does, the main advantage of the Page Object Model, as you can see from the disadvantages of the waterfall approach, is the separation of concerns. So you should just, if you want to have one mnemonic trick to remember what POM even does, it's the separation of concerns. So what I mean by separation of concerns is that, let's imagine we have the website again. I won't, of course, draw everything again. Let's just try to imagine that it's the same thing that was the before. So we have some buttons and stuff like that, headers and so on. So if you remember in the previous method where we just tried to translate what a test case from a manual tester perspective looked like in the code, when we just tried to convert it straight away, you remember that we just tried to convert it into a manual test case and then into a script, and that's it. In Page Object Model, we divide it up into at least two, we'll talk about it in a second, in two paths. So first of all, when we have a page like this, we create what we call a page class. So a page class. And so this is a script which models everything regarding the actual object of further testing apart from the testing. So in the page class, you have the locators, you have the action methods. You may also have some resources, though this gets tricky, but let's stick to it. You may have some resources. they may actually be, you may want to have your resources in also another file than the page class itself. Sometimes they reside in the same space, so that's why I'm listing them there. But let's put them in the parentheses, because generally you want the locators, the action methods, everything you need to have if you want to interact with the website. So locators, because you need to have a way to pinpoint the elements, and the action methods because you need to have a place where stuff like this will be coded, like navigate in or logging in, or finding like some specific element because you need to do something on the website before you can access it. So all the things that you need, all the things that you can think of the page class as all the things you may need as a preparation to actually start your testing. So the page class, basically, you should think of it as something that sets the stage for testing. So the page class, it sets the stage for actual testing. So this is the whole idea behind the page class. And then you create the second thing, which is the actual test class. And then inside you have test case number 1, test case number 2, and so on and so forth. And the way these two work together is that for each of these test cases, let's imagine you have the test case here. So this is like some set of steps. Whenever in some of these steps you need to interact with the actual page, for example, you need to be logged in before you do that. We usually use something called the test setup or the suite setup. We'll also talk about it in a separate video, but then it is taken from the page class. So, for example, in the test class, if your test case is validating a form, when you try to address a specific field in the form, you don't keep the locator here. You don't keep the locator in the test class. In the test class, you have the steps, you have the test case, but all the data needed to interact with these elements is kept in the page class. So, for example, if you want to log in, if you want to have some method that, for example, interacts with your navigation, or if you need to do some manipulation on the website that is external from the test, like it also only prepares you for the testing, you have it in the page class. Even inside the things that you are testing, like I said a moment before, the text fields or the buttons and stuff like that, even though they are being tested in the test class, the locators for them are kept in the page class. So basically, you can think of the page class as something that sets the stage for actual testing and that keeps all the data. So in that way, the test class is not really concerned with how the data is kept, how it's structured. It just knows that if it needs to, it can use the page class to actually take something that would model the actions of a human being on a website. And so right now, I think you may see the utility in that. But an even more important thing starts to happen when you have more test classes, like we talked before. Let's say you have another test class. Let's call it test class 2. So this one will be test class 1. And then again, in test class 2, you have test case number 1, test case number 2, and so on. And then suddenly, when you need some locators from the page class because you are operating on the same page or you're operating on the same part of the page, because the page class does not have to represent the whole page, and that's what I said that we're going to talk about in a second. So then the page class number 2 may again and just take from the page class. So as you can see, you have the separation of concerns because you have all the page modeling data in one place and the test data in another place. And so if you do actual testing, you are relying on a single code base for all the locators, the action method, and stuff like that. So if a test fails, you know that the test fails and not that you made a typo when copying locators between files, or that you made a typo copying the action methods, or that the action method was actually updated in one place, but it wasn't updated in another place. It doesn't happen. It won't happen because you have one repository of the data regarding this specific page, and it is the page class. And so you may have 1,000 test classes, all of them, for example, needing the login before they can proceed. And you just have one page class, which contains the locators needed for the login and the action methods needed for the login, and possibly the credentials. This is the resources in parentheses, because you may have them in another place. Where to keep your credentials is a topic for another video. So we'll talk about it in specific detail some other day. But it may happen. So yeah, the test classes, they all take from the page class. And this is an ideal situation because then when something changes, you just change it in one place and suddenly it changes everywhere because they are all just importing the page class and using the resources from the page class. So if you change it once, it changes everywhere. If something is needed to be changed in the action method because the method of logging in changed or the placement of the buttons and stuff like that, you change it once, it changes everywhere. If you suddenly need to create a new test class, you don't need to add all this stuff and just have a headache about what to import and why. You just import the page class and everything is there. You can actually reference it as if it was in the test class itself because you are importing the page class and using its resources. So it's very easy, and it also prevents you from having to deal with possible problems that you may have if you just had everything in one place. So even though it may seem a little counterintuitive, even if it may seem a little illogical in the beginning, if you are not used to something like that, it makes perfect sense why once you start using it. Of course, it adds some overhead because you need to think about it in the realms of having two separate paths and maintaining both of them. But believe me, you will more than make up for the initial overhead in the long run. This is something you can maintain. The waterfall method is something you can't maintain in the long run. So now to actually elaborate a bit on the point that I teased like twice already, which was that the page class may not be the whole page. So let's scroll down a bit. So when we say page class, in the case of more elaborate web applications, it may very well be that a page class is actually a tree-like structure. I know we are talking about trees all the time, but that's how testing goes. It's trees all the way down. So when you have a page class, it may actually be that it is using other page classes, and these classes are using other page classes. So for example, it may be that you have like one page class. Let's just call this one page class. Page class main. And this one may actually have the separate page classes for like navigation, or maybe even for the header navigation. So like the header nav. Then it may have the page class for sidebar, and it may have the page class for the footer, and so on and so forth. So the page class can also reference other page classes. So it may be that you need to atomize it a bit, that you have smaller parts taking place in this whole shebang. So it may be that the page class that you are importing, because you in most cases you will be importing this one, but it may also be that you need a very specific, more narrow part, and then you can reference actually something smaller if you don't need all the locators and methods and stuff like that. But this is getting like into more technicalities. In general, you will usually import the main page class, but this page class may actually consist of other smaller test classes also. So just as the test case may actually reference the page class may reference other page classes. Then you don't need to worry about it in the test itself. You don't need to worry what's like under the hood of the page class, because it's there and you can reference the things from it. But the page class may actually consist of other things. And this is also a very big advantage. So it may look like something, a problem that you need to think about it again. But no, it actually is a great advantage again, because what if you then have different page classes and then you can just reference the smaller page classes for smaller elements into those page classes. So then again, you have the same advantage that you had with one code base for the tests. You have the same advantage for other page classes, which makes modeling them easier, because why reinvent the wheel? Why create all the locators again if they are present in different places? Why create all the action methods anew when they are just there? You can just reference them. So this is how it goes. You also may have different page classes which also make use of it. So you may have like another page class main 2, and this one is 1, let's say, and it uses this, but it also has something unique to it, just like this has something unique to it. And so you have this tree structure happening where they may interact with each other through like referencing each other's sub-page classes also. So don't get too married to the idea of the page classes being a page class. It may be sub-page class or something like that. And the page class that you reference may very well consist of smaller parts also. So all of this is actually great for you. It allows for a layering of the page classes and the layering of your problems too, because then again, when something changes in the sidebar, you just change it in the page class representing the small part of the application, which is the sidebar, and suddenly all the main page classes are up to date. And the fact that they are up to date allows you to have your tests also be up to date. So it is very good. It is modular. It allows you for portability. It allows you for reusability of all the things. And so you don't reinvent the wheel. You have less proclivity for error. You don't repeat yourself. So this is also like one of the programming paradigms. Dry, don't repeat yourself. Also, keep it simple, stupid. So you try to atomize it to the most extent possible and then go from there. And by having it like that, you actually have, when you have the test, it is actually the foundation block, but upon it, you may have the page class, and this page class may consist of other sub-page classes, and these may contain other sub-page classes, and the more elaborate your web page becomes, the more possible it is that if you try to follow the rabbit hole of references, that you actually will see something like that. You will see a whole pyramid built like blocks upon blocks of various page classes and resource files and stuff like that. But this is a good thing. This is a good thing. You don't need to worry about that, because this just means you create once, but you use it forever, instead of having to deal with the whole ordeal every time you create a new test. And so this is actually a good thing. And even if it's some overhead in the beginning, it actually helps you in the long run. This is also an industry standard. So to be honest, you don't really have too much choice. If if you want to work in modern projects regarding test automation, you will need to use something like that, because in large scale projects, nobody does like the waterfall method of having everything spaghetti into one file. So this is the way, and this is actually way easier. It makes your life way easier. And as a test automation engineer, it'll make your life with maintenance of those scripts also way easier. It'll make creating new tests way easier, because then you can just reference the stuff and like you're done with it. So that's actually very good. And this is the page object model. So once again, let's reiterate the main pros and cons of page object model. There won't be many cons, to be honest, but I'll try my best to try to stay objective here. No pun intended. So like the main pros, I would say, first of all, it's the reusability of code. So like we said, you don't need to reinvent the wheel. You don't need to create the same stuff again and again. You don't need to have the locators scattered across different files and suddenly you are at a loss. You don't know what's happening, why this is here and why that is that. All the helper methods for interacting with the GUI are neatly placed in the page object classes, and all your tests are in the test classes. So it's all good. You don't need to worry about the code not being reusable, because it is reusable. You have the blocks that allow for the reusability, and the locators are just placed once. Another thing is the modularity. So like we discussed a moment before, since it allows you to build these nice pyramids, it allows it to be modular, because then suddenly you can just pick some of the blocks and build a completely new pyramid. You can suddenly take like this one and this one and this one, and then you will reference it in like a completely new page class, and then you will create a test underneath it, and suddenly you have built a completely new pyramid where actually the only code you have actually written was here for the test. This is the test, and this is the another page class. So page class number 2. This is number 1. So suddenly you have just like carefully cherry-picked the things that you needed, and you have built a completely new pyramid, fully functional, with all the helpers already there, with all the action methods, all the locators, everything there. The only thing in need of your actual work is the test itself. So there you perform the eventual final validation of this stuff. But all the things that came before it, you already have it. You already have it, and you have it tested in battle, because you know that all the tests from before will work and they work properly. So you can just do it. And in such a way, you have built a completely new thing. And this is the great thing about the page object model. It is its modularity. Another thing is no code duplication. And this ties in a bit to the first point, of course, but not totally, because here I also mean not only the reusability, but also less clutter in the code itself. So you have no code duplication. So suddenly the classes are way neater. They are cleaner, shorter, and you don't have the problems with the same stuff lying around everywhere, and suddenly you don't even know what's happening. So the no-code duplication is a bit of the dry principle, like don't repeat yourself. So it's less proclivity for error. It's easier navigating through the code. It's basically easier on the eyes, more readable for you. And last but certainly not least is easy maintenance. So this is a big one. Like I said, the first example that we did at the beginning of the lesson, the wrong one, the old school one, or the one that you may think of as the proper one if you have never done automation, this one is a nightmare to actually maintain in the long run. And this one will prevent many of the headaches that the other one will like be the main culprit of. So the fact that it is modular will allow for easy maintenance, because then you can just refactor this very specific object in the whole pyramid and just change it there, and suddenly everything starts working. It allows for easier additions easier removals, easier refactors. So everything becomes easier with the page object model. When you have it coded once, it works everywhere. If something breaks, it also may break everywhere, but that's good, because if you have it in separate like files, if you have every script being its own kingdom, then suddenly if something breaks, then you have different various weird errors happening, because every script is giving you a different line, and it's giving you a fail state at a different place. And even though you will eventually understand what's happening, in the beginning you will have no idea. So you will just see a ton of different errors, and you will feel like the whole framework just collapsed on you. While if you have it neatly separated into modules and in the page classes and test classes, when something breaks, you will still have the same test cases failing, but they will all fail with the very same error code. They will fail because of the same reasons. You see, like, even if you are just eyeballing it, you're seeing the report in the morning, you're checking, and suddenly you have 100 errors of the same kind. So then you know what was the common denominator, you know what was the common culprit, and it's just perfect. Why not use it? So this also allows you for easier maintainability of the whole code base. So these are all great pros, and let's try to think of some cons. So I would say that it may be less intuitive in the beginning. So I would say that, yeah, if you are starting out, it may be less intuitive in the beginning, but you will very shortly make it a second nature, and then you won't really imagine how you could do it any other way, especially if you ever saw it done any other way and it worked in a situation where it was done the other way. Then I can guarantee you won't ever want to have it done again to you. But even if you are just learning it, then it is only less intuitive in the beginning when you want to try to cram everything from like human way of thinking into the machine. But very shortly you will see that it is not less intuitive. It makes all the sense in the world when you just get accustomed to it. So it may be a little like hoop to jump over at the beginning, but very soon it won't be a problem at all. And the second thing, maybe let's just say that it's the initial overhead, like I mentioned before. So yeah, in the beginning, it does add some overhead. So if you compare it to just cramming everything into one place, then of course, in the beginning, it will add some overhead because you need to plan it more, you need to structure it more, you need to reference it, you need to think about how it intertwines with all the things in your framework. So you need to know how this page class needs to reference other sub-page classes, how it works together. You still don't want to repeat yourself because it won't make sense if you are doing POM and still repeating yourself. So you will need to check whether some of these parts or sub-parts were not like covered before in the script, in the framework already. So it does need some initial work and initial overhead, but the longer you want the project and the more you know the code base, the less relevant this is going to be. And also, like I mentioned before, you are going to make way, way more advantages in the long run by using POM than the accumulated short-term gains if you decided not to do it. So the initial overhead may look scary, but it is not really anything that is an actual problem. It is still a form of getting used to, and it is just an investment, but I wouldn't even call it an investment because it's a guarantee profit in the long run. So yeah, I wish there were more investment like this. So these are the cons, but like I said, none of them I think actually matter in the big picture. And so I think we can jump into the summary of today's lesson. So the first thing you should remember is that POM is a design pattern separating the page classes from the test classes. So this is the main thing. This is what we talked about right at the start. So this is just a way of separating the page from the test, and so allowing it to be more reusable, more modular, easier to work with, easier to maintain, easier to read. Basically, flowers and sunshine all around. The second thing you should remember is that POM allows for the separation of concerns. Like we've also extensively discussed, it allows you to have the various parts of the application kept separate, and you can actually make it even more modular than it is by just separating the page class from the test class, which is already a lot. But you can make it even more modular by just then dividing up the page classes into sub-page classes and stuff like that, and then cross-reference them from different places and have it all create a very nice tree structure, which allows you to work with more prepared environment for your testing. So which allows you to actually create the tests with more ease and with more maintainability in the long run. And so the final thing is that, for better or worse, for me, definitely for better, but since it's new to you, maybe it's for worse to you, but I really don't get discouraged, is that POM is the industry standard. So like I said, for better or worse, because like for me, it's like I said, you can see that I just think that it is the better way to go about it. And I would say that most of the test automation engineers you're ever going to come across will tell you the very same thing. POM is the industry standard. So the page object model is something that they use everywhere. It is something that they are going to ask about in each and every interview you are ever going to probably be interviewed in. And so I have never come across a company that has ever said like, yeah, so the page object model, we don't really do that here, right? Could you please add more spaghetti code? I have never actually came across anything like that. So I don't think that there is anything you can do about actually adhering to these rules. But the good thing is, it is not really a pain. It'll pay you off in the long run. It's not only for the good of all the organization, it's also for the good of you, because it'll make your life as a test automation engineer way easier. And with that, I thank you very much for your attention for today's lesson. I hope it has been informative for you. I, as always, invite you to participate in the discussion in the comments, to also visit our website or our Instagram, and I hope to see you in the next lesson. Thank you very much for your attention, and keep on rocking.